Welcome back to the BrainBox AI podcast. This one's a really interesting one. We had the opportunity to talk about a project that we did with Loyola University, where we implemented BrainBox AI's AI for HVAC technology, as well as this new algorithm called the AER algorithm. AER standing for Automated Emissions Reduction. We explore various new algorithms, new M&V methodology, and really talk about how this is going to make a huge difference for buildings as we enter the energy transition, as we have more renewable energy in our grid, and why algorithms like an AER algorithm is really going to make the difference. Gentlemen, hi, welcome. Thank you all for being here. Today's an exciting podcast. We're going to talk about a lot of things, a lot of very interesting and fascinating things that touch on energy emissions and energy management. But maybe to get us started, we could do a little bit of a round table and have you each introduce yourselves so that our listeners can get to know you a little better. Josh, I'll hand the ball over to you to start. Just introduce yourself.
Thanks, Reb. Yeah, no problem. I'm Josh Mullen. I am a product manager at BrainBox. I've been with BrainBox for about 3.5 years, and I work closely with the commercial application of our algorithms. And for this project and with these two colleagues and partners, I'll call on Geoff to introduce himself as well.
Thanks, Josh. Hey, Geoff Hancock. I'm at WattTime. WattTime's a nonprofit that obsesses about researching electricity grids and providing actionable data about grids so that consumers and companies can make better decisions that reduce environmental footprint, carbon emissions, and other pollution. Paul?
Thanks, Geoff. My name is Paul Raftery. I'm a staff researcher here at the Center for the Built Environment at UC Berkeley. Been here about 10 years or so, and I focus basically on researching the built environment, primarily on HVAC systems and their controls in large commercial buildings.
Amazing. Such interesting backgrounds, complementary, similar at the same time. So we're here to talk about a very interesting project that you collaborated all on, the Loyola University project. So maybe to start us off, Josh, can you just give us a lay of the land? What is this project about? What were we trying to accomplish?
Yeah, so this project, and I'll probably use some of Geoff's knowledge, but this project was funded through the Great Lakes Protection Fund, and they were researching ways to reduce emissions in the Great Lakes area. So we coordinated and partnered with WattTime to try out a new algorithm, which is automated emission reduction. So we were trying to take advantage and consume more power anytime renewables on the grid are being curtailed, and then charge the building as a thermal battery and allow that building to thermally drift anytime renewables were no longer being curtailed. So we would consume less dirty energy and reduce overall emissions. Geoff, is there anything I'm missing?
Maybe some of the history of GLPF. They've provided some funding to WattTime over the years, so a big thank you to them for a lot of years of support. They particularly care about mercury pollution. That's one of their focuses.
Mm-hmm.
So the aim of their collaboration with us is to reduce mercury pollution from the electricity sector. And so this project, like Josh was saying, the goal was to commercialize a technology that will use more clean power, use power at times when more clean electricity is being generated, and use less power at more times when particularly coal power is what's being generated.
And was there a reason we decided to work with Loyola more than another building?
Yeah, so this was almost 3.5 years ago, and it was a new technology at the time. We approached many clients about deploying this new technology. Loyola was the most eager. Their sustainability partner is great and supportive about, their sustainability department is great and supportive about trying out new technology. And they allowed us to use the Schreiber Center, which is this beautiful building in downtown Chicago, as a test bed for the automated emission reduction algorithm.
If I'm not mistaken, I think maybe a testament to their sustainability avant-gardeness is also that they're LEED Gold certified, if I'm not mistaken.
Yeah, the building was new. It was built in 2015. It's about 150,000 square feet, LEED Gold certified, and the HVAC system was very cutting edge at the time. It has radiant heating and cooling, chilled beams, you name it, in terms of newness and esotericness of the HVAC system, and they had it, yeah.
I think that's, when I was reading more about this project, I thought that was a fascinating choice, and that's why I wanted to ask you all that question of why we decided to go with that building, because it seems like a more challenging ask, right? To go for a building that already has had a lot of sustainability initiatives put into it. It's a pretty new building. So, I mean, it's good that we accepted that challenge, and I think it makes perhaps the results of this project even more impressive because of the baseline we started with.
Yeah, I mean, the ideal case would have been an all-electric building, because we're really trying to reduce the Scope 2 emissions, or the electric grid emissions. But we did, Loyola first selected an all-electric building for us, but it was slated for a construction retrofit halfway into the study. So we pivoted to this building, and we were able to deploy it. And as Paul said many times when I was like, this building's going to be complicated, he said, the best building for a case study is the building you're allowed to be in. And
I love that.
I think in an ideal world, you'd have, 1 million buildings to choose from, and very engaged owners and operators, and you could cherry pick one that meets exactly the criteria you're looking for the study. But the reality is that there's, a limited amount of time and effort you can put into that outreach and contacts that you have, and you have to choose from the options that are available to you. And this is one building, and it has one set of characteristics. If it was a different study, you would have a different outcome. But I certainly agree that it was already a very high performance building to start out with. That's definitely the case.
Don't shy away from a challenge. So now I'd like to talk about, maybe you guys have mentioned in this introduction, BrainBox HVAC technology and AER algorithm. Can we dig into that a little more, just to give our audience some additional details?
Yeah, so I guess the industry term for what we do is advanced supervisory optimization, or advanced supervisory control. So BrainBox is we like to call ourselves an autonomous HVAC optimization company. And we sort of sit over top of a building's control system, and we communicate to it, and then we communicate up to our cloud. And in the cloud, we can push in different types of data. So for this project, we were pulling in the WattTime marginal emission data to give us a signal if renewables were being curtailed on the grid. We're also pulling in granular weather, rate tariff structure we can include as well. And once we have all this HVAC telemetry data up in the cloud, we can run our algorithms and calculations against this. A lot of times we use space temperature predictions, so forecasting an hour or two ahead to know when we should optimally start or stop equipment. And our algorithms are really looking at the conditions of the space, the operations of the equipment, and then deciding if they should write back to the equipment and to the controllers themselves. And if we think there's an opportunity to increase efficiency by changing the set points and changing the parameters of the equipment, we do. So we write back to the building level controllers. I will say, Ren,
Josh,
and I know. Sorry, go ahead.
I was just wondering if you would characterize like the standard BrainBox deployment as kind of efficiency focused, and
Yes.
And that's slightly different than this new algorithm, which essentially kind of, it doesn't reduce the overall energy that's used in the building. It simply shifts it from one time to a more optimal time.
Yes, absolutely. I would say the AER algorithm is emission saving focused, where our traditional algorithms are energy focused, and as a byproduct, you get emission savings. And this one puts emissions as the primary component.
Is that why WattTime is called WattTime? I just heard you say you shift from the one time to the right time. I think I just clicked. Smart.
Yeah. Yep. It's kind of a corny name, but back in 2014, I think it was when WattTime was founded in a hackathon. That was the idea. It was a question: what time should I use electricity?
Smart and cute and memorable. Okay, so WattTime's MOER, seems to be a critical element in properly doing AER. Can we talk about that a little more?
Sure. So, like I was mentioning in the intro, WattTime studies electricity grids and tries to provide impactful data signals so that companies can make better decisions about electricity. And the primary signal that we create is called the marginal operating emissions rate. It essentially characterizes on a particular grid at a particular time and place what is the emissions impact of using more or less energy at that moment. So it characterizes, if, say, I plug in my electric car, which power plant is going to respond to serve that extra power that's needed for that electric car. So in certain grids, you have coal or gas plants responding, and in other grids, you might have a surplus of renewable energy at a certain time. Like in California, there's a lot of solar. There's actually many times of the year, there's actually too much solar on the California grid. And so a lot of that solar effectively gets wasted. They just turn off big utility scale solar plants. And so really our marginal emissions signal aims to provide that indication of when there's opportunities like that. So we're really highlighting, especially in this project, when is the best time to use electricity? It's when renewables are being wasted. Because if you use an extra kilowatt hour during that time, that just allows that solar that would otherwise be wasted to be absorbed into the grid. So you're effectively, when you use energy at that time, you're kind of unlocking this otherwise wasted renewable energy.
And like, as an energy engineer, like I have decades of energy engineering experience, like this was a fairly new concept for me to get my head around when we first started to engage with Geoff, because most energy engineers, they see emissions as one annual number. The times are changing now, and they're starting to look at it as an hourly number. But just getting your head around, like, emissions are constantly changing, and the plants that are responding are changing, and you can optimize your energy use based on that is a fairly new concept. And we had to collectively, as a whole, to develop an algorithm to take advantage of it, get our head around it. Renewable curtailment as well was another thing that I was surprised that was happening. But once you look at it, you're like, oh yeah, that makes sense. Paul, go ahead.
Yeah, like I was just to piggyback off that. It was certainly the first time I think that anyone has done automated emissions reduction in a large commercial building's HVAC system. That was, I think you guys would know, right, Geoff? If somebody was doing this in other buildings based on marginal emission signals, I don't think anyone has done this before.
I think it was the first commercial deployment of AER in a commercial building was in Paul's backyard at Sitarjadai Hall. WattTime was born on Berkeley campus, and so there was a deployment early days, really just testing to see if AER, automated emissions reduction, could work as a concept. So that was technically the first commercial building implementation, but at a much smaller scale.
Was that in the HVAC system, or was that the plug loads?
I think it was.
Or lighting?
It might have been both plug loads
Okay.
and HVAC.
Gotcha.
It was before my time.
Yeah, it was before mine too, I think. Or I wasn't involved in that study. But
So obviously, it's a project. I am hearing you guys talk it through. It has a lot of variables. It's a very new thing that's been done. It's one of the first projects to really include AER in a big commercial building setting. Obviously, one of the important things with a project of this nature is to see, does it actually work, right? Is it actually making a difference? It's fun to implement new technologies and new ideas, but the ultimate goal is to have an impact. So I think that's where I'm going to pivot to the M&V, measure and verification portion of it. How did we ensure that was done really in a top of the line way, and to ensure that the results were super reliable?
yeah, I can take this one. So the process of kind of trying to figure out what impact a particular change in a building has is called measurement and verification. And that's kind of shorthand in the industry for kind of doing a baseline of a building to capture its performance, making some change, and then measuring how that has, impacted performance. But one of the issues is that buildings change a lot over time, right? They're highly variable from day to day, and depending on how occupancy changes and weather, they can change quite significantly. And if you need a kind of long time period to capture the effects of different seasons, then those changes in occupancy or operation or major changes in the building can have a really big impact on these types of pre-post analyses. And usually when you change something in a building, it's something pretty major, right? You replace the windows or you replace a chiller, and it's not something that you can easily kind of switch on and off and test in a different way. That's kind of your only option. But here, because we're testing out control strategies, we can do a kind of testing that in other fields is called A/B testing, or maybe switchback testing, where we're basically switching between different control strategies pretty frequently so that we get a kind of sample of each control strategy's performance over the whole distribution of how that building is working over the course of, say, a year or so. And that gives you a much more accurate answer, because if a tenant moves out of one floor of the building in the middle of your study, you get samples of all the control strategies both before and after that tenant moves out. If you just kind of switch once, you could have a really big impact from that tenant move out. And that's the approach we followed here, which is in itself a pretty novel way of doing M&V, and that will improve the kind of robustness of the findings and also find an answer a little bit faster. So here in this particular study, we were actually switching between 3 control strategies. So we had the kind of building as it was before we came on board as a team, and then we were testing kind of BrainBox's typical deployment as Geoff and Josh were mentioning earlier, kind of the focused on efficiency and energy savings. And then we had a third control strategy that was just focused on this emissions reduction using AER to respond to kind of dynamic grid conditions. And we were able to test those 3 strategies in the building by switching randomly, basically each day at midnight. We'd kind of flip a coin and say, like, today we're going to run strategy 1. Tomorrow we'd flip the coin. Well, maybe we'd run strategy 1 again. Maybe we'd run strategy 2 or 3, depending on how that 3-sided coin kind of landed, so to speak. And that randomization gives you a really good result over a long time frame and allows you to really break out what the difference is of these control strategies between each other in a very kind of precise way. So that in itself, I think, was a kind of an interesting part.
Is having those three strategies typical, or is in classic M&V, is it also done in that way, or is that a bit of a novel approach?
Yeah, like typically it's only pre and post, so you'd only be able to kind of test two, a baseline and whatever the after the change, whatever the kind of intervention or the post retrofit case would be. If you wanted to test three strategies, you'd kind of have to do them in sequence, right? Maybe you replace the windows, you measure the performance, and then the next year you replace the chiller. You wouldn't be able to break them out independently in a way like this, and it would take so long that, like, who knows what else has changed in the building over that time frame as well.
Yeah, and because, and Paul touched on it, because we're a control overlay, we can change seamlessly between different modes of operation. So like, we're not changing the building's program sequences, we're more adjusting them from the cloud, writing down, but the underlying control sequences exist, so we can seamlessly flip between the three modes. The one thing that was challenging, we found out, was the intermittency of the renewable curtailment. So, as we randomly go through these 3 days, for the AER day, like, all the stars needed to align. It needed to be a day where renewables were curtailed. So there were enough curtailment events. And it happened frequently enough that we were able to quantify the impact. But Chicago, it's in the PJM territory, and it doesn't have as much volatility in the renewable curtailment as others. Like Geoff, you typically point to like Southwest Power Pool that has a lot of wind curtailment.
Yeah, so like a little bit to the west in the Great Plains. So think Nebraska, South Dakota. These areas are on a different electric grid region called Southwest Power Pool. There's a lot more wind energy already built in that area, and so this signal that we're talking about that measures curtailment is very volatile in that place. It's almost every day you have some wind curtailment happening, and it makes big swings in the signal, and so we kind of think of it as a postcard from the future, because the Chicago area and the PJM region is likely to be a wind-heavy region as it builds more renewable energy. And so it's in about 5 years, plus or minus a few, depending on how fast wind and other renewables are built, this region in Chicago will start to look more like Nebraska over those years.
Right, and it's not just wind too, right? Here in California, basically every day there's almost in the middle of the day when the sun is out, there's way lower emissions on the grid and a large opportunity to shift. Even if it's not being curtailed, the grid emissions are dramatically lower on the marginal emission side in the middle of the day in a typical California day. So that would have been, I guess we would have been able to detect savings faster or more accurately, because we'd have more example days where, the grid emissions dropped low enough that it triggered the AER algorithm to take action in the building.
Yeah, totally. So I think what we saw here was that on some days in Chicago, there wasn't, it might have been activated as an AER day, but there wasn't a renewable curtailment event on that day. So essentially it just operates like the baseline mode for that day. So if this building had been in Nebraska or California, there would have been a lot more days where we actually saw an intervention on that control strategy.
It would be a fascinating next project to have maybe a building in another place. As a marketer, I can't help but take this opportunity to promote the academic paper that was published on this topic. Paul, maybe you can tell us a little bit about that, but I think it's a great resource for those that are wanting to dig deeper.
Yeah, so to clarify, the paper hasn't been published yet.
Oh, I'm
It's still
sorry.
in the journal review process, but there's a preprint available that's accessible online publicly, and we hope it will be published soon, as soon as it gets through the peer review process.
I'm foreshadowing here.
Yeah. Well, it's available. It's public information, but the actual publication isn't out yet. So.
Yeah, and the case study was also published in the ASHRAE decarbonization guide that the new building
That's
institute
right.
helped implement.
Yeah, so 2 great resources. Perhaps we can plug them at the end of this podcast for those who want to see the paper and who want to see the ASHRAE case study. So, Paul, maybe I'll just ask you another little follow-up question here. I learned that you were a facilities engineer for quite a while, so maybe you can put that hat back on. What's your...
Oh yeah, it's been a while.
What if we, looked at what has been your observation going through this MNV process with the BrainBox solution and the AER algorithm? How do you see that impacting the building space, maybe at a larger scale? You see
Sure, yeah. Like many in what feels like a previous life, I was a facilities engineer right out of college. So I worked on that side before I went back and did a PhD and focused on the research side. But because we do demonstration projects in real buildings all the time as part of my research, I work with a lot of facilities engineers and understand the kind of constraints they're under. And one of those really is kind of time to focus on these things, and having a system like BrainBox that can come in and generate these emissions reductions or generate these efficiency benefits in an automated and standardized way is a big benefit there. And I think particularly as systems become more complex and there's more opportunity to shift, like as we have more all electric buildings, there's going to be more and more need to do this type of shifting work. And that's going to be harder to achieve in a kind of a standalone implementation that's just kind of following some kind of rules-based sequences that are in place today.
Great answer. Thank you for bringing us back to your engineering days. So I guess now the next thing is everyone wants to know, what are the results? We did a great MNV process. We had a technology that was really novel, interesting. What happened? What came from it?
Yeah, sure. So we had these 3 strategies, right? The baseline, which is the building as it was before we did anything, without any of the algorithms in place. And then we had the kind of BrainBox standard deployment and the annualized savings. So projecting those savings out to a typical meteorological year was 10% for the HVAC electricity in this building from the BrainBox deployment. But again, this was already a very high performance building with a very low EUI to begin with. So I think that was quite compelling. And then for the AER algorithm, that third algorithm, when there was an event on the grid where the grid emission signal from WattTime indicated that there was renewables being curtailed, the BrainBox AER algorithm was able to detect that curtailment and basically start pre-cooling or preconditioning the building during those periods of time when the grid was basically very clean and efficient. And then as soon as the event ended, or the actual marginal emissions window changed, so the grid emissions were much higher, they would stop preconditioning and kind of coast through the subsequent period, and they would have much lower energy consumption during that window of time. So when we looked at the data and compared all of the randomly selected days when the AER algorithm went into effect versus otherwise comparable day when the AER algorithm did not go into effect, we saw a 15% reduction in carbon emissions during that kind of combined event window of the curtailment and the coasting right afterwards.
And that coast period was a 4-hour window, Paul?
That was a 4-hour window. So the kind of initial start of the event where the grid marginal emission signal drops off and renewables are being curtailed, that could vary quite a bit in time, right?
Yeah.
It could be, an hour, it could be 2 hours. And then the coasting period where we're trying to measure the savings after that kind of preconditioning was 4 hours in this case.
Perhaps something to mention too, with the fabulous results is we did this while maintaining comfort in the building, right? Without switching the parameters of the set points and just not impacting the occupants, but having a huge impact on emissions and energy.
And that's exactly right, and that's also in the paper in the supplementary material as well. So that was if you're a facilities operator, it's all well and good to save energy, but you have to keep the occupants comfortable. You have to serve the primary purpose of the building, which is keeping folks comfortable and healthy and productive. So you can't kind of compromise on that.
Negate that part.
Paul, does Berkeley CBE know anything about building occupant comfort?
That's kind of like our research group has, been around 20 or probably closer to 30 years at this point, and the primary focus of it is building science research, but historically we've done a huge amount of thermal comfort research here at CBE. We actually run one of the world's largest post-occupancy evaluation surveys. So we can survey the occupants in a large office building and compare how that building is performing to a database of hundreds of thousands of respondents across thousands of buildings. We've done a lot of thermal comfort related work over the years.
Paul, just as an aside, I was playing around with your ASHRAE 55 comfort tool on your website today, messing with the metabolic rate and seeing the impact on comfort. Because most of the time you think people are just sitting at an office, but what if they're walking around? What if they're packing in a store? You got to take that into account. I was seeing the shift
for sure.
Impact.
And how many clothes?
Well, my favorite one is the my favorite one is the kind of more dynamic impacts where I bike to work, right? So I bike into my office and I get in, and my office might be perfectly comfortable, but I arrive and I'm kind of sweaty and uncomfortable, and it's that's all to do with metabolic rate and thermal comfort. So definitely.
So Paul, you said you took a look at the comfort for the study too, and didn't find much of an impact there. I think you were looking at set point adherence, or how are you doing it for this?
Exactly right. Yeah. So we were comparing the basically the actual measured temperature on the thermostat against the defined set point range, which is a kind of a heating and a cooling set point in the building. And that set point range, the amount of time the thermostat measurement was inside that range was the same across all three strategies as far as we could tell from the data. There was no, even statistically significant difference between those.
Now, to be clear, when a renewable curtailment event occurred, we did pre-cool the building. So we dropped the space temperatures down a degree or two during that curtailment time because we needed to charge the battery, right? That building is a thermal battery. We're trying to charge that thermal mass. And then when curtailment ended, we allowed it to drift back up. But it wasn't more than, it's still within the heating and cooling dead band that we were playing with. We weren't dropping it down drastically.
Exactly right. So specifically what we're looking at was the hours of exceedance. So basically how many hours in each zone in the building did the actual temperature exceed that predefined comfort range. But yes, you're right. The actual temperature was decreasing a little bit during the AER event, specifically because of the pre-cooling, but it's still within that that range of temperatures the building operators had selected for those zones.
I think that was super impressive that there wasn't a difference there in comfort. And also, I think because of the complexity of this building and how it was set up, there may be other opportunities in other buildings where you could take advantage of thermal battery in an ice tank or thermal
Yep.
battery with the chilled water loop. And so like, I think there's a lot of applications where you may not even have to change space temperature set points and you could still achieve similar results.
I think
Domestic
that's a
hot
great
water.
point. I think domestic hot water in a multifamily building is the ideal one. You could get a really large and a really long load shifting period there with almost no impact at all on the occupants. But I also think, if this wasn't such a new high performance building to begin with, you'd see a pretty large difference in just the energy savings from a typical deployment, right? There'd be more flexibility there because we weren't starting with such a high performance baseline to begin with.
That's exactly what I was going to say. The stats are very impressive, but we were starting with a building that was already very high performance. So it'd be so fascinating to see that in a browner or dirtier building that has had less green initiatives. And would be so inspiring to see how the impact that it would have on global warming at a larger scale, right? If this project was implemented in 100 or 1,000 buildings, the results would be dramatic. The impact would be dramatic.
Yeah. And I think what you're seeing is all buildings are different. They're different eras of construction, different climates, different use types, right? And now we're also layering on this complexity of different grid emissions windows, right? As we talked about earlier, if you did this study in a location where there was a lot more opportunity for load shifting, you would also see larger impacts there. So we have this additional new complexity of what the grid is doing, which I think is really interesting. And it's certainly going to be one of the challenges for building operators and designers for years to come.
And the thing
ahead,
that
Josh.
the thing that surprised me was that the more renewable, and it makes sense once you know it, but the more renewables come on the grid, or the larger percentage of the grid mix it becomes, the more renewables are curtailed. And that was surprising to me. Geoff, do you know off the top of your head, which regions see the most curtailment? And if people are at home and they want to know, is there high volatility and should they be paying attention because they can have an impact whether they charge their electric car or whatever? Do you have
Sure. Yeah. Right now in the U.S., CAISO in California, SPP in the Great Plains, and ERCOT in Texas are all grids that have pretty frequent renewable curtailment. There's also some renewable curtailment happening upstate New York, where there's a lot of wind power as well up there. The other grids don't have as much curtailment yet. It's essentially tracks, like Josh was saying, when you build more renewables, when it becomes a bigger portion of the overall generation, you're going to start seeing more curtailment happening. That's not a rule, but it's what happens everywhere, not only in the US. It's happened in Germany and other places around the world where renewables have been built fast. So there are a number of different solutions to that. Building better transmission lines can help with that, because renewable curtailment is a local problem. So if you are able to share that excess renewable energy with your neighboring regions, then it doesn't become wasted. It's essentially like, if you don't use it here, try sharing it with your neighbors. But if you can't get it to your neighbors, then it's going to go to waste. And so that's how transmission can help. Also, using more energy within the region helps, which is what we've been talking about. But essentially, because we're trying to build renewables very fast, this approach of having these buildings be grid interactive and kind of help out the grid by soaking up this excess, it actually de-risks the prospect of building more renewables, because right now it's starting to become risky in some places to build more renewables when it's kind of unknown how much they'll be turned off and not able to produce. So by doing these strategies in buildings and helping helping out the grid with these good grid citizens as buildings, we can actually make more room for new renewables to be built and in a faster way by deploying these strategies. So this is going to help not only the grids that already experience curtailment, but also the grids that are coming along, like PJM in Chicago and where I am in Michigan, MISO. There's a lot of aggressive plans and ambitious plans to get to 100% clean energy by 2045. And by empowering these buildings with this technology, we actually help accelerate that future by making more room for these renewables on the grid.
Yeah, I even do it myself at home, honestly. Here in California.
Were you alluding to the fact that we can, as just mere mortals, see when the grid is greener?
Exactly right.
Where?
Yeah, like you get. Well, in some regions, it's very correlated with solar, right? So in California, you can just generally, the more you can kind of shift your electrical consumption to align with when the sun is up, the more renewable energy you're going to use, and the less curtailment that will happen, and the more investment in solar resources that will happen, and ultimately the larger the reduction in emissions. So if you can run your dishwasher at noon rather than at like 10 p.m. or something after you go to bed, that's going to basically cut the emissions from that choice of running your dishwasher from basically close to zero in California. In other regions, where it's not immediately clear when something is being curtailed, a tool like WattTime would be able to give that clearer indication. Well, in every scenario, there would be a much clearer indication, but in scenarios where it's not like immediately obvious, like in California, it would be essential to have something like that.
Yeah, I think as consumers, we kind of need help, whether it's automation to do it for us or just some kind of indicator that makes it easy for us to know, like, when to use energy. I think Josh was holding up one of the examples of that.
Yeah. So
your watch tells you when you have green energy?
So in the States, with an Apple Watch, it'll tell you when the grid is expected to be cleaner, and you can take advantage of charging.
I'm living in Montreal. We're all hydropowered, so I'm definitely the odd one out here. But that is so cool. So cool.
This emission signal that we've been talking about is available as a forecast. So essentially, on your Apple Watch, it'll show you like the next 8 hours, and it'll have a little green bar that shows when the best time is to use electricity. So you can say, oh, it's going to be cleaner at 6 o'clock than it is right now, so I'll wait to run my dishwasher until then.
Amazing.
And so there's a lot of different companies utilizing WattTime in numerous different ways. Some large tech, and Geoff, you know better than I do, but like some large tech firms, they have changed their updates. Their computer pushing updates to be aligned with grid cleanliness. Some use it to like broadcast when you should charge your batteries of whatever device you have, and others have used it to like in a residential application. So what we're doing in large commercial buildings, they're doing in your own home. It's like, because it's all about using batteries, whether chemical or thermal, in a smart way.
Yeah. And I think it's on the way into consumer products too, right? Eventually, like everything from your refrigerator compressor to your heat pump water heater could, in theory, automatically be doing this in the background. And I think that's a really exciting kind of future where it just kind of happens in the background, and this load shifting, you don't even necessarily need to be aware of it. It's just kind of happening all the time.
That's when it's best.
Yeah,
When it's just happening and you don't have to do anything, that's probably when it's most efficient. This has been really great. I don't know if any of you have a last thoughts on the Loyola project to share. If not, I will jump into what we call our rapid fire questions, which we make our special guests go through. But any last thoughts before we jump into that?
I just wanted to thank the Great Lake Protection Fund again and Loyola University of Chicago. Their sustainability department was wonderful in allowing us to use their building as a test bed. It was a perfect building and perfect test bed for this.
Great point, Josh. Thank you for that. And we'll make sure to call them out when we share this podcast. So, Josh, I'm going to ask you to send this one out. We make our special guests, non-brain boxers, go through this. And
Nice.
The goal is we are so privileged to have many brilliant minds come to this podcast, and we like to just take the last few seconds to pick at those brains to get a little bit more intel that's not necessarily related to the topic of the podcast. So 3 questions. Try to answer them in a sentence or less. The first one, and we'll go Paul, Geoff, okay, every time. So first
great.
one is, sorry, I just chose that randomly.
Alternate randomly.
It's okay.
We should do that.
Switch back.
Where's your three?
Flip a coin.
Where's your three-sided coin? So the first one is, what is one book you would recommend? It does not have to be related to this topic of HVAC and buildings.
Oh, it doesn't have to be related. Well, that's an interesting one. Nonfiction or fiction?
Either or.
Not okay. Well, I guess nonfiction is probably better. I read the book *Sapiens* a year or two ago. It's about the evolution of humanity over time, and it was, and I found that absolutely fascinating. It was a great book.
Did you read the full novel or the graphic, like the comic book version of it?
I didn't even know there was a comic book version.
I read the comic version of it. It's very good. It's very good. Good for teenagers
cool.
too.
I got to check that out.
Yeah. Geoff?
I'll definitely check that out.
I enjoyed that book. I didn't know there was a graphic novel version either. With a toddler, I'm not doing much reading, but we had a book club at WattTime recently that I couldn't resist. We read The Ministry for the Future by Kim Stanley Robinson. So I really enjoyed that. It's essentially a kind of ambitious, or the stars align really well by the end of the book for how things could turn out with dealing with the problem of climate change. And the premise is basically there's a ministry created to advocate for future global citizens. And so how does that affect the how we deal with climate change?
Perfect.
Yeah, that
for
was
when
a
you're
great
bringing
book.
the next generation into the world.
Exactly.
Okay, question number 2. Again, 1 sentence or less. What is one action that can impact building energy efficiency the most, which you would consider like a low-hanging fruit?
Well, there are lots for existing buildings, but the one I most frequently talk about is correcting the ventilation flow rates at the zone level in a building. It's almost never done by commissioning agents in or retro commissioning projects, but we've found in past projects that can really generate very substantial savings, and it's effectively just a set point change. And you can save 20-30% of HVAC electricity in existing buildings doing this.
My answer is somewhat similar. I would say just more generally, like operating buildings, existing buildings better. And a lot of that is just fixing things that are broken, or fixing schedules that are not what they're supposed to be. Like someone just makes a schedule override one day, and then it just continues that way for years. And so I think we kind of need to treat our building operators a little bit better and respect their time, empower them to spend more time reviewing these things more often, and do a quarterly schedule review and make sure everything's
working,
running as it was intended. Yeah.
Okay, great tips.
Yeah, I couldn't agree more.
Last one. What do you think the evolution of AI brings to energy efficiency in the fewest words possible? What does AI bring to energy efficiency?
Well,
Paul, I'm going to give you a break. I'm going to go to Geoff.
No.
Yes.
Oh, great. Even better. I have more time to think through my answer.
So, I mean, Josh and I were just at a conference last week together, and I had heard your announcement recently about your new AI feature, and I wasn't quite grokking like exactly how it was going to help. But I think it's the perfect answer to this question, because following up on my last answer, like, these building operators need more time to just deal with things that could actually affect performance. And I think this AI feature that you guys have, which Josh could probably explain better than I could, but it will help them answer questions about their building, like, hey, which zone is is most often misbehaving or out of temperature band, comfort zone, and it can just pull that up and give the answer. So, like, I think it just empowers these building operators to spend less time digging through logs and worrying who's going to call next, and just bring those answers much more easily to the surface.
We're calling it ARIA, or the virtual building assistant, but generative AI, using generative AI to help FMs. That's a good answer. And Paul, you get the last word.
Oh, this is so I'll come at it from a different perspective. So I'm fascinated by the evolution and the growth of AI, but also the computing infrastructure and the energy implications of that come with this. You might not see it, but like every time you make a query on a computer to one of these things, there's an enormous data center with huge power consumption requirements spinning up a computer basically to answer that query, and the increased demand for that has caused that infrastructure to like really increase. And I think the intersection between what we're doing, like automated emissions reduction, and that infrastructure is really fascinating, because that can be readily shifted around to some extent through different data centers in the country. And I wonder, is it possible to be able to do that in response to automated emissions reduction? I don't know, because I don't work in that area, but it's just something I think there might be a synergy there that would be interesting to explore.
I can answer that.
Oh, great.
We do some work with an organization called the Green Software Foundation, and they're looking at applying AER to data centers and how the energy is, how computing loads are scheduled, and so this takes it from WattTime to also what place is the best place to use energy, because often you have a choice between data centers around the country or around the world that will run your job. So it's like, well, I need to run this compute job at this time, but I have flexibility about where it can run.
Right. That's cool. So you're going to have to rebrand to what place? Is that the...
Yeah.
What everything.
What? Josh, Paul, Geoff, thank you so much for the time that you've spent here today and explaining this amazing project. And we hope that maybe this is the first of maybe more podcasts with you guys. And thank you very much. And we hope to talk again soon. Thank you.
Great.
My
Thanks
pleasure.
very much.
Yeah, thanks for having us.